गुड मॉर्निंग गाइस। कैसे हैं आप लोग? आई होप यू आर फाइन। तो इस वीडियो में हम लोग केमिस्ट्री के एक अहम टॉपिक के बारे में डिस्कशन करेंगे। वो टॉपिक है पीरियोडिक टेबल। पीरियोडिक टेबल इज द अरेंजमेंट ऑफ एलिमेंट्स अकॉर्डिंग टू देयर एटॉमिक नंबर। केमिस्ट्री में पीरियोडिक टेबल को हम बैकबोन ऑफ द केमिस्ट्री कहते हैं। पीरियोडिक टेबल में सारे एलिमेंट्स को यूनिक सिंबल और एटॉमिक नंबर के आधार पर अरेंज किया जाता है। इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऑर्गेनाइज द एलिमेंट्स बाय एटॉमिक नंबर, इलेक्ट्रॉनिक कॉन्फ़िगरेशन एंड रिकरिंग केमिकल प्रॉपर्टीज। हिस्ट्री ऑफ पीरियोडिक टेबल। द पीरियोडिक टेबल as we know today is culminated of century of scientific inquiry. It represents a remarkable journey of discovery with contributions from numerous scientists across the globe. The development of the periodic table is a fascinating saga of observation, experiments, and the restless pursuit of understanding the fundamental building blocks of matter. Early attempts to organize elements based on their property means बहुत पहले जब अरेंजमेंट किया जा रहा था तो केमिकल्स को एलिमेंट्स को उनकी केमिकल प्रॉपर्टी के बेसिस पे अरेंज किया जा रहा था। बाद में से फिर मेंडलेव साहब 1960 में एक पीरियोडिक टेबल्स को प्रपोज किए थे। फिर मेंडलेव के पीरियोडिक टेबल में भी कुछ कमियां थी जिसको मॉडर्न पीरियोडिक टेबल्स में रेक्टिफाई किया गया। मॉडर्न पीरियोडिक टेबल इज रिफाइनमेंट बेस्ड ऑन द एटॉमिक स्ट्रक्चर एंड प्रॉपर्टी। साइंटिस्ट लाइक जॉनसन डुबेनियो, जॉनसन न्यूलैंड्स made early attempt to arrange elements based on their atomic weight and recurring properties. In 1960, Dmitry Mendeleev revolutionary work in organizing elements by atomic weight and chemical properties led to the development of first recognizable periodic table. Later, refinements were made based on the understanding of atomic structure and the concept of atomic number. Atomic structure and the periodic table. Periodic table is organized based on the atomic structure of each element. We know that the atom contains proton, neutron and electron. We know that the proton and neutron is centered at the nucleus, but electron keep revolving around the nucleus in fixed orbit. Elements are arranged by increasing atomic number, which represents the number of proton in atom's nucleus. In modern periodic tables, the elements are arranged according to the atomic number. When we move from left to right, the atomic number increases. The periodic table also highlights trend in chemical property, atomic property, like atomic mass, which is the total number of protons and neutrons in the nucleus. Now, let's come to the periodicity of the periodic table. First, we discuss about atomic radius. Atomic radius is the distance between the nucleus and the outermost orbit in which the outermost electron present. Atomic radius is the distance between the nucleus of atom and its outermost electron cell. This trend shows that atomic size generally increases as we move down a group and decreases as we move across the period. Means when we go down in a group, the atomic radius increases, but we move from left to right in a period, atomic number decreases due to the increased electronic attraction. The number of electron cell increases, leading to a large atomic radius. Moving across the period, the number of protons in the nucleus increases, leading to stronger attraction between the nucleus of an electron. resulting in a smaller atomic radius. Second is electronegativity. Electronegativity is the ability of an atom to attract the bonded pair of electron toward itself. Electronegativity is a measure of atom's ability to attract electron in chemical bond. It increases across the period, meaning the elements of right side of the periodic table have higher electronegativity. And this is because the atom becomes smaller and attraction of nucleus to the outer electron is stronger. Electronegativity decreases down a group in periodic table. This is because the size of radius increases. We know that the highest electronegative element is fluorine, whose value is 3.98. After fluorine, the oxygen is the highest electronegative element, then chlorine, then nitrogen, then bromine, then hydrogen. Due to the high electronegativity, fluorine, hydrogen and chlorines are able to form hydrogen bond. Ionization energy. The ionization energy is the minimum required energy to eliminate one electron from its outermost orbit in gaseous state. Ionization energy generally increases across the period and decreases in a group. It increases across the period due to the small radius of atoms. This is due to increased effective nuclear charge and increasing the distance between the valence electron and the nucleus. Groups in periodic table. Vertical column is known as group. In vertical column, all the elements have similar property. They all have same valency. For example, in first group, there are alkali metals whose valence is +1. Similarly, in alkaline earth metal, second group have valency +2. Now, next is in periodic table, the three type of elements are present. First, metal, second, non-metal, and third, metalloids. Metals are shiny, malleable, and ductile. They have good conductor of heat and electricity. So in periodic table, the left side is alkali metal, then alkaline earth metal, then transition metal. These all are metals. On the other hand, on the right side, like fluorine, chlorine, bromine, nitrogen, oxygen, they are non-metals. They are dull, brittle and poor conductor of heat and electricity. These also exist in solid, liquid or gas. There are some elements in them which have the property of both metal and non-metals. Those we call metalloids such as silicon, germanium, arsenic, antimony, etc. First is alkali metal. Alkali metal is a metal of group 1 whose valency is 1. The alkali metals are soft, silvery white and have low melting point, but they are good conductor of heat and electricity. Alkali metals are not found in nature in their elemental form due to their reactivity. They remain in combined form in our environment. Second group is alkaline earth metal whose valency is +2. The most common alkaline earth metal is calcium, magnesium and beryllium. Calcium is essential nutrient for a strong bone and teeth. Magnesium is important for muscle function and nervous transmission. Third is halogen. The 17th group is called halogen. It contains fluorine, chlorine, bromine and iodine. They are highly reactive nature due to the presence of 7 valence electrons in their outermost orbit. The name halogen originates from the word halos, means salt. Halogens are found in variety of everyday products, including salt, toothpaste, and disinfectant. They play an important role in various industrial processes and are essential for human health. Noble gases. The 18th group is known as noble gases. helium, neon, argon, krypton, xenon, and radon. These elements do not participate in reaction because the outermost orbit is filled with the 8 electrons. They are colorless, odorless, and unreactive gas. They are found in very trace amount in atmosphere. Neon and xenon are used in lighting applications like neon signs and high intensity lamp. Argon applications. Argon is used in incandescent light bulbs to prevent filaments from reacting with oxygen. Right? Now, transition element. From group 3 to group 12 is your transition elements. These elements are known for their ability to form colorful compound, possess high melting and boiling points, and exhibit a wide range of oxidation state. The oxidation state varies from +3 to +6. Transition metals are vital component in various technologies applications such as alloy, catalyst, and electronics. The unique property including conductivity, strength, and reactivity make them essential material for wide array of industries. Next is lanthanides and actinides. At the foot of periodic table, there are two type of elements is there. First is called lanthanides and second is actinides. Lanthanides belongs from 58 to 72 atomic numbers. The lanthanides and actinides are the two series of elements found at the bottom of periodic table. These elements are known for their unique electronic configuration and reactivity property. The lanthanides are characterized by their filled 4f orbitals contributing to the similar chemical property. The actinides are known for their radioactive natures, with most being synthetic element. Application of the periodic tables. Periodic tables are used to identify the chemical reactions, medical advancement, electronic device, and environmental solution. The periodic tables help to predict the outcome of chemical reaction. किसी भी chemical reaction का outcome क्या होगा ये predict करने में हमें मदद करता है, enabling scientists to design new materials and process. The periodic table aids to understanding the behavior of elements in the human body, contributing to drugs development and medical treatment. Right? Next, electronic device. Today we use a various type of electronic device. All devices are constructed with the help of semiconductors. So this periodic tables guide the section of elements for electronics, which is crucial for designing efficient and reliable technology. Last is environmental solution. The periodic table assists in comprehending environmental issues like global warming, air pollution, water pollution, helping to develop sustainable solutions and protect the planet. So this is all about the periodic table in this वीडियो. यदि आपको मेरा वीडियो अच्छा लगा तो काइंडली लाइक करें और सब्सक्राइब करें और अपने फ्रेंड्स को भी फॉरवर्ड करें. मिलते हैं अगले वीडियो में एक नए टॉपिक के साथ. तब तक के लिए थैंक यू. गुड बाय.